This video we're gonna try to illustrate how HTTPS work. HTTPS. This is for hyper text transfer protocol. Okay, so it starts with a user. So this user using your maybe a mobile application, and it wants to use a service from, say for example, facebook.com. So let's try to abbreviate it to fb.com. So fb.com has its server, so let's put it here like this, servers. So it has a cloud of servers. So let's just focus on this one here, server. So it wants to send its username and password. So using the browser, so a mobile phone has a application called the browser, and this is for viewing websites. So it uses the browser and it wants to input username and password. So username is maybe JB and password is PW. All right. So it wants to send this to facebook.com. But we want to send this securely so that other people, like this one here, this bad guy, using its maybe laptop, cannot intercept our communication line here. This one here will not, they cannot intercept the data passing through our communication line, our network between our device and the Facebook server, so that it can be wired or through like wireless, so like data transfer. So we don't want other people to intercept this data. So how we can do this is we want to encrypt this. So our browser can do encryption so that it can encrypt here. So there'll be like symmetric encryption. So that it will have like a symmetric key. So key, your data plus key is equals to encrypted data. So this encrypted data here, let's put this in a red envelope. You can then send this to facebook.com. But facebook.com doesn't know what is our key here, because encryption, you can decrypt it using the same key. If it's symmetric or using a private key, if it's asymmetric. So we'll talk about that later, or maybe in the next videos. But for now, we cannot unencrypt, so we don't know what is the username and password. So we cannot validate the username and password because we don't know what are those data. So to solve this, there's a idea of using a public key and then there's also private key so that whenever the browser here wants to send this data, it first encrypt the data using the public key. So public key, it will first say I want to send, it will make a request to the server to inform the server that it wants to send this data here. I want to send the data, so the server will give me a public key. So using the public key, we are going to encrypt the data with a public key. So public key plus encrypted key plus the key plus the data is the encrypted key. Then it's going to send it to the server, and then the server, you will decrypt this data using the private key. So now you can have access to the username and password. But sometimes hackers can still intercept the initial call to the server to request to send data. So instead of the server sending a public key to the user, it will be the hacker that is going to send its public key. So our machine here will think that this is the public key from the server, so it will encrypt the data, this username and password, with this public key, and then it's gonna send this to the server, but it will still be intercepted by the hacker, and it can decrypt this data using the hacker's private key. So to fix this, we will introduce the certificate authority, so that when the user wants to send a data, it will go to the server, and then the server will go to a certificate authority and will ask for a certificate. So the certificate will look like this. The server sends a public key to the certificate authority, and this public key will then be added into a certificate. So the certificate will have the information of the server, which is IFB, and the certificate authority, the DigiCert. Then it will put here the public key plus the public key plus private key of the certificate authority, public key. Then it's gonna send this back to the server, and then the server will send this certificate to our machine. Our machine will then evaluate the certificate from the information of the certificate. So it goes to the DigiCert, and then it will ask for public key. So the public key will be given to the machine, and then the machine will then decrypt the certificate. So it will decrypt this part here. Well, and then it can get the decrypt the encrypted key here, and it will check if it's the same public key with the public key of the server. So once they're the same, that means this public key here is the public key. Is a trusted public key, and it didn't come from a hacker. So it can then use this public key to encrypt our data and send this to the facebook.com, and then facebook.com and then use this private key to decrypt the data so that it can have the username and password. Okay, cool. I think I'll have to exercise this like a million times so that we can get this digested into our head. Right, cool. Thanks. Bye.